So in this video, we're going to talk about arithmetic series, and we've discussed arithmetic sequences before, and recently we just talked about the relationship between series and sequences. So in a similar way, an arithmetic series is going to have the common difference, just like the arithmetic sequence had a common difference as well. If you decide something is arithmetic and you want to add up all of the terms, there's a formula where the n represents the number of terms, the a sub 1 represents the first term, and the a sub n represents the last term. Now that a sub n representing the last term, that might be a little bit hard to understand initially, but if you think about it, if there are 12 terms, then a sub 12 would just be the last term. So a sub n would be the last term, a sub 1 would be the first term, and n would be the number of terms. Okay, now the next thing we're going to do is actually going to prove this, but before we prove it, we're going to just look at a really basic example here, and I'm going to show you the strategy that we're going to use. So the sum of 2 plus 4 plus 6 plus 8 all the way to 50. Now, first of all, you can see that that's a series. We're just adding a bunch of things up. And the other thing to notice is that it is arithmetic. There's a difference of 2, a positive 2, between each of the terms. Now, the next thing I'm going to do is actually take this series and just write it backwards. So I'm going to have s equals 50 plus 48 plus 46 plus 44 all the way to plus 2. So I just, again, literally took the same thing. Addition's commutative. I wrote it backwards now. And so we go 50 to 48 to 46 to 44 to 42, all the way down to where we started at 2. So now I'm going to take this. I'm going to add these two things together. On the left, we're going to have 2s. And on the right, this is where you'll see why writing it backwards is helpful. When you add this, that gives you a 52. When you add that, that gives you a 52, 52, 52, and 52. So really, we just have a bunch of 52s added together. And how many is a bunch? Well, in this particular case, we're going to have 25 of them added together. So there are 25 of these 52s, the 52s. And I know that because, again, we started at 2, we go to 50, we're counting by 2, so I know that there's 25 numbers in this series. So another way of writing that is 2 times s equals 25 times 52, which now, when I divide by 2, and I expand this just a little bit, you can see that s would equal 25 over 2 times 2 plus 50, which there sits your n, there sits your first term, and there's your last term. So a real simple example like this will help us in just a second now when we go ahead and we put the actual proof together. All right, so now in the actual proof, we're going to start with an arithmetic series that you see on the screen, and we're going to have to be a little bit creative in how we represent this. So now, remember, there's a common difference between all of these terms. So a sub 1 and a sub 2 have a common difference. So in other words, the second term would be a sub 1 plus whatever that distance is, or difference is. The third term would be a sub 1 plus 2 times whatever that distance is. The third one would be a sub 1 plus 3 times whatever that difference or that distance is. All the way out now to the nth term. Okay? So now, I've got it all expanded out, and I'll go ahead now and I'll rewrite it backwards. So this would be our a sub n plus a sub n minus d plus a sub n minus 2d plus a sub n minus 3d plus all the way to a sub 1. So again, notice how I wrote that and going backwards now, where we're still taking advantage of that common difference between terms. So now, when I add these together, that's going to give us a 2 s sub n. And so when I go ahead and add there, I'll get a sub 1 plus a sub n. And notice when I add here, notice how the d's go away. So I'm going to have a plus a sub 1 plus a sub n. Similar on all of these. Notice how the two d's go away and it leaves us with the a sub 1 plus a sub n. And it's going to do that again all the way to the very end, where in fact we still have our a sub 1 plus a sub n. And there we go. You can see that all of those are the same term. And how many do we have? Well, looks like we have n of them. So another way of writing that would be 2 times s sub n equals n times a sub 1 plus a sub n. And if I divide by 2, then I actually get my desired formula of n over 2 times a sub 1 plus a sub n. So there's the overall formal proof for that. The earlier example might have given you a little bit of insight as to why we're doing what we did now and writing in reverse order. And you can see it works out wonderfully. All right, so in this example, they want us to find the sum of the series. Now, to be clear here, they want us to use the formula and not just write out all the terms and add them up. So again, using the appropriate formula. Now, first things first, if we're going to add this up using the appropriate formula, what's the appropriate formula? Well, the only one we have so far is the arithmetic, and is this arithmetic? And I can definitively say yes, it is arithmetic very quickly, because if I look up at this function, it's linear. So I know there's going to be a common difference between the terms. So since that's linear, we know it's arithmetic. We know we're going to use the formula that we just proved, which tells us we're going to need to know n, we're going to need to know a sub 1, and we're going to need to know a sub n. A sub 1 is the first term. So for the first term, this is where we're going to take the 4 and plug it into the I. So if I take the 4 and plug it in, my a sub 1 is actually going to be 6. The last term, a sub n, is when we go ahead and we take the 11 and we plug it into the I, which is going to give us 11 over 2 plus 4, which is 19 halves. And then finally, n would be the number of terms. Well, we start at I equals 4. We go to 11, which tells us that there are 8 terms in the series. So once we have all of that information, we can say that the sum of the 8 terms is going to be 8 over 2 times 6 plus 19 halves. So 4 times 31 halves, which is going to give us a 62. So the sum of the 8 terms is 62. The only thing that really I should probably go back and mention again is, for example, a sub 1 does not mean to plug 1 in to the formula. A sub 1 represents the first term. The first term is going to be found by taking the first number, 4, and plugging it then up into the index.